Hello, good evening, my lovely warriors. I hope you guys can see me as well as hear me. Do let me know in the chat box. Hello, Kirtavaran, Deepak, Sai Charan, Miram, Darshini, Sai Charan. Welcome, Vamu, Fancy Facts, Ganeslav Gunda. Welcome, guys. I hope I'm audible as well as visible. Welcome to the first lecture of your legendary series for all the 11th standard kids who have just moved from 10th standard. Well, even if you are a 12th or a dropper student, you can still watch this. But yes, primarily this is for your JEE and NEET aspirants who are aiming for the target exam in 2024. So all the students, JEE NEET 2024, who want to learn in English, welcome aboard to the first lecture of units and dimensions with me, Shreyas, your physics master teacher. Good evening, Ganesh. Good evening, Debojit. Hello, Kirtavaran. Welcome, Vignesh. Everybody is on fire and all excited. Get all your friends, get all your classmates, get all your batchmates, because the fun is about to begin. With me, Shreyas, your master teacher out here. I've been with kids for a very long time now, more than 10 years. And I'm very happy that in the last more than 10 years, many of my kids have done very, very well. And I'm very happy that many of these kids are now in the top-notch positions, top-notch colleges in and outside our country. So your journey with me begins here on this channel, We Enlite. And we are going to stay together till the end, just like we are still with your seniors who are still about to finish all their final exams. Like you have seen, we have been very regular, very up to date, and provide every bit of detail that students need for their final journey. So let's begin this class. And if you want to be my friend, yes, that's my Instagram handle, captain_Shreyas. Good evening, Charita, good evening, Dinkar. Nice to see you guys. My branch was mechanical. Hello everyone, and make sure you have smashed the like button and also hit the subscribe button down there. I can see all the kids right over here. Good evening, Mohadeen. Hello. So a lot of you will also have many doubts as to, sir, where to study from, which books to study from, and what is the right way to study, how to make notes, or how to solve problems, and so many other doubts which might come during the course of your studies. Don't worry, we have your back. You don't have to bother. I will definitely conduct many sessions on how to actually study, how to make notes, how to revise, and we'll be conducting many problem solving sessions as well. So you don't worry, just stay tuned. Make sure you have hit the subscribe button so that you do not miss any of my classes. Okay. Kailash Bhaskar, it will be done much before January. I am targeting October or November, right? So around that time, hopefully we would be done with most of this stuff. Don't worry. All right. So let's begin with the class, guys. And to start with the class, I am asking you a simple question. How happy are you right now? How happy are you right now? Just answer this question in the chat box. There's a first class Aman Chauras here. I'm not sure, Charita, if it is fine, but I've heard it's very rigorous right from morning till evening. It's up to you. Sai Charan, I'm from Bangalore right now. I would suggest, Charita, more time should be given for self-study. If you're getting self-study time, then it's fine. All right. So Black Diamond, I'm very good. Somebody says this happy, somebody is very happy, somebody does not want to speak. Okay, somebody is like, don't know. All right. Debojit, to join my course, there is a link in the description box. You can check it out. You can join my course. So guys, remember that happiness, you can probably express it. But if I ask you, tell me a number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, 10 point something. Are you happy? 10.1? Are you 2.7 happy? You'll be like, what nonsense are you talking, sir? I don't know. I can't tell you like that. I can just express it. I do not like something. How much do you not like it? I don't know. So these things cannot be measured. But there are things like how much money do you have? That can be measured. How much money Ambani has, probably he also can't measure. Anyways, so similarly, if I can say, what's your height? You can tell me a number. If I ask you what's your weight, you can tell me a number. So things which can be measured are basically called as physical quantities. Examples could be temperature, height, weight, mass, speed, acceleration, so many things. And physics is always about numbers. So that's why we start physics by defining what is a physical quantity. Without defining a physical quantity, there is no point starting a physics class. I hope you guys agree. Yep. Now, this is an English channel, MD Tariq. Welcome, Ghazi Azhar. So, now let's say for example, you go visit a doctor, you're not feeling well, you have some fever. So, is fever a physical quantity? Is blood sugar level a physical quantity? What do you say? What is the answer to this? Is your fever a physical quantity? Is blood sugar level a physical quantity? Yes, even current is a physical quantity. Hello, Sefina. Good evening, Prajwal. Nice to see all the 10th standard kids here, finally here. When we started the channel, you were, I think, very young, 9th or 8th standard. And now we are here. Yep. Is fever a physical quantity? The answer is no. But is blood sugar level a physical quantity? Yes. You can measure your blood sugar level. It will be, I don't know, so many grams of blood, sugar is there for these many ml of blood. It's a physical quantity. Your temperature is a physical quantity, right? Your height, weight, these are physical quantities. I have fever, doctor. I have very high fever. What is the meaning of high fever? I have very mild fever. This is very approximate terms. You cannot measure it. You can tell me the temperature. That is measurable. Very good. So guys, welcome to the first class. Those of you joining in late, first class of the Legend series. Whenever you see the word Legend, remember it's the 11th standard series for all the JEE NEET aspirants. And this is an English medium channel, so we'll be obviously using pure English out here. Now, when you talk about physical quantities, there are two types of physical quantities. Some are very basic, like you need these quantities for talking about something else. You need something for knowing something else. Like you might have heard, you see a complicated word. When you see a complicated word, you explain it using simpler words. So there are simpler quantities, more elementary quantities, more empirical quantities. They are called as fundamentals. There are some other quantities which depend on these basic quantities. They are called as derived quantities. Now, the most elementary or the fundamental quantities. So there are basically these fundamental quantities. They are very basic. They are very basic. And using these quantities, you can get quantities which are based on this. They are called as derived quantities. Example, let me tell you, mass, length, time are fundamental quantities. So when I talk about velocity, or speed, then I am talking about the displacement and the time. So this displacement, time, they are fundamental quantities. This is your derived quantity. This is derived quantity. It depends on this. Same way, if I say density usually symbol rho, or you can also use the symbol d, is mass by volume. Volume is not a fundamental quantity. In fact, volume depends on the radius or the cube length or something like that. So let's say for example, it is a cube. Let's say for example, it is a cube. The volume of a cube is basically the side whole raised to 3. This mass and this side are basically fundamental quantities. Volume depends on the side. Even volume is a derived quantity, and even this density is a derived quantity. Now, who decides which is fundamental, who is derived? So there is a committee. There are scientists, there are researchers. They sat down, they analyzed all the physical quantities. Then they saw, oh, this quantity comes here also, here also. This quantity depends on this and this. Oh, this quantity is there here. Without this quantity, I cannot express this quantity. So they sat down, they analyzed, and then they came up with the most fundamental quantities. And everything else is based on these quantities. So there is a list I would love to give. These are the only fundamental quantities. If you're wondering, sir, this list will be like in pages. No, it is not in pages. It's very small. Length, fundamental quantity. Length means side, the distance, displacement. All these are fundamentals. Mass. Not weight, mass. Mass is in kgs. Time, how much time you spend, hours, seconds, minutes, whatever. Current, how much current is flowing through a wire. Temperature, you can measure it in Celsius, Fahrenheit, Kelvin, you will learn different units. Amount of a substance, you will see it in chemistry, it is expressed in moles, how many moles is there. And luminous intensity, you will probably hear about it in 12th standard, it is the intensity of that light, how much light is there and all of that. Don't worry about these things. For now, just play around with length, mass, time, that is more than sufficient. Okay? Now, your entire 11th standard, most of the time, at least 60 to 80% of the time, you will be just bothering these three quantities. In fact, if you have enrolled into coaching or if you are in Vedantu or any other book you are studying or any lecture series you are following, you will see for the first 5-6 months or 4-5 months, only these three quantities are talked about. Then you will see temperature somewhere. Current comes next year. Amount probably towards the end of the year of 11th standard. Intensity probably next year. So most of the times you will see this. This you might see in chemistry, amount of a substance that's small. Everybody clear? Anything else like speed, acceleration, force, pressure, all other things are derived quantities. What about charge? A lot of people think charge is a fundamental quantity. No, charge is not a fundamental quantity. Current is a fundamental quantity. Charge depends on current into time. In fact, that's how charge has been defined. Current is fundamental, okay, not charge. So these are the things which you should know. Let's see how many of you can solve this question. Come on, everybody put up the answer in the chat box. I want to see all the lovely students. That way I'll get to know you more. Other students can know you and you will make new friends. And this is a long journey that you're going to, follow and you're going to be on this channel. So make sure that you are very active. We will not judge anybody even if you give a wrong answer. Sajid, I will be doing all the important concepts of the chapter because there are lecture series of mine from last year. So I won't be covering everything. I'll be doing only the important stuff from every chapter because I'll show you there is a beautiful playlist called as the Nurture playlist that will be very helpful for all the other concepts. I'll be focusing on some very crucial concepts and problem solvings as well. All right. Hello, Prajwal. Thank you, bacha. All right. None of these? Sure. Let's see whether you guys are correct. Absolutely correct. The temperature can be expressed as a derived quantity. No. Temperature is not a derived quantity. In fact, temperature, like you can see over here, is a fundamental quantity. It's an empirical, basic quantity. So temperature is not a derived quantity. It is a fundamental quantity. You can see that. It is a fundamental quantity. So you cannot express it in anything else. Moving on to the next question. Which of the following is not a physical quantity? Which of the following is not a physical quantity? I'm so glad, Prajwal. Awesome, bacha. I'm so proud of you. Awesome. I would love to see you till 2024 and we are going to rock and celebrate together because I want to party with you guys here after 2 years. Because this year I'm going to party with the 2020 students, 2022 students, right? They'll be celebrating their results and their colleges and their branches. So after 2 years, we are going to celebrate together. Your IITs, your branch. KG, option D, option C. Okay, let's have a look. Very good. Length, time, current. These are physical quantities. Kilogram, you'll be like, sir, kilogram is also a physical quantity, Mass is a physical quantity. Kilogram is not a physical quantity, it is the unit. Yes. Time, yes, it's a physical quantity. You can measure time. Length, you can measure length in meters. Current, you can measure it in amperes. Kilogram is not a quantity. Kilogram is how you measure mass. Kilogram is itself how you measure mass. You cannot measure kilogram. Kilogram is already measured. You know what is 1 kilogram. So, kilogram is the odd one out here. Mass is a physical quantity. So now you will be like, sir, I often get confused. This meter and length, technically what's the difference? Mass and kilogram, what's the technical difference between them? Seconds, hours and time, what's the technical difference? So that's how now we introduce what is the meaning of a unit. Now, if I ask Muniz, Niharika, Amazing Shot, Sai Charan, CH Sanjay, Sucharita, Vishali, what is your height? Or what is your weight? Then one student will be like, sir, my height is 5 feet, sir. Sir, my height is 5 feet 2 inches. Something like that. So each student will say, sir, my height is something, 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 something. So when I say the height of a person, this height of a person is a physical quantity, and I might say something like 5 feet. Now this number 5 is the value or the magnitude of that physical quantity. Magnitude of the physical quantity. This feet is called as the unit of that physical quantity. This itself is the physical quantity. Physical quantity. Every time you see any physical quantity, it will be always value into unit. Unit is how you measure it. In what terms are you measuring it? You can measure it in meters, you can measure it in centimeters, you can measure it in kilometers, you can measure it in feet, you can measure it in inches. So different ways. And you know what a unit is. Like when I say 1 meter, you know, oh, this much is 1 meter. 1 centimeter is this much. Even in America, even in India, even on the moon, on Mars, anywhere. It's a fixed, standard, universal thing. It does not change with time. Sir, 100 years back, sir, 1 meter was this much. Sir, now 1 meter is this much, sir. That is not a unit then. Sir, today 1 kg is this much. Tomorrow, you know, 1 kg is this much. Nah, then how can it be a unit? It has to be standard. If I say 1 feet is this much in India, in US also 1 feet will be this much only. It can't be different. It will be funny, right? If it is different. So unit is fixed, universal. You cannot change it with time, place, pressure, temperature, nothing. It cannot change. It's a fixed thing. It's universally accepted fact. These researchers, scientists decide. Acha, we will decide. You can also make your own unit. You can form a group and say, sir, I made a new unit, sir. Sir, my height is, let's take somebody's name. Reuben. Reuben says, my height is 1 Reuben. 1 Reuben. Then tomorrow, Vishali says, sir, my height is, you know how much? My height is 1.5 times Reuben, sir. So Reuben is a unit. Reuben is a unit. 1.51 is the value. I hope you guys got it. So Reuben is our standard. But that's not a good standard. Because I'm pretty sure Reuben is going to grow in height. Now he's in 10th or 11th, sorry. Tomorrow he will be in 12th. And then he will pass out. He will go to IIT. By the time he goes into IIT, he will grow. I don't know what is going to happen with Vishali. I don't know. So you cannot make it as a standard. So Reuben is not a good standard. But Reuben can make his own unit. Right? Very good. So always you will see any physical quantity will be the magnitude times the unit. N into U. N is your value. U is the unit. Physical quantity is always number into unit. The number is the value. U is the unit. Awesome, Reuben. Awesome, awesome. Make your dream come true. Who is that? Yes. Great. Now, I have put all the things. By the way, you'll be getting the PDF, okay? You'll be getting the PDF in the Telegram channel. Just download the Telegram app. Make sure you are into the Telegram app and click on the link which is there in the description box below. You'll get the entire PDF of today's class. But just reading the PDF is no fun. Obviously, you have to watch the lectures. That's how you are going to understand things. Let's see how many of you can get this. Which of the following is not the unit of volume? Which of the following is not the unit of volume? Difference between heat and temperature. Heat is the flow of energy. Temperature is the measure of the energy of an object. Heat is the flow. Like I transferred 10 rupees from A to B. That 10 is that heat. This person has 1 lakh rupees. That measure is with the help of temperature. So account transfer is heat. How much amount you have in the bank, that is measured using temperature. Alright, I hope that makes sense. Ganesh. Option A, somebody says none. Come on guys, decide on an option. There are 5 options, not 4, 5 options. Okay, students are confused. Answer is E, none of these. Very good. Hello Teja, Suri Seti. Why is it none, bacha? It's simple. Cc is a unit. Centimeter cube. This is basically centimeter cube. Side into side. Cube, volume. Liter, obviously. I want 1 liter of milk. Okay. ml, obviously you measure ml. And you all know 1000 ml is 1 liter. It's volume. Meter cube, it's less like centimeter cube. That is also volume. So answer is none of this. All of them are units of volume. So cc is volume unit. cc is the volume unit. You might have heard in engines, this is 1800 cc. This is 200 cc engine. 200 cc means if you take a block 1 centimeter by 1 centimeter by 1 centimeter, that is basically having a volume of 1 cc. So 2000 cc means 2000 blocks of 1 centimeter. Okay, I hope this is clear. Oh, by the way, you should know this. 1 cc is nothing but 1 ml. 1 cc. If you take exactly 1 centimeter by 1 centimeter by 1 centimeter, that will be exactly 1 ml. That is how ml has been defined. Moving on to the next concept. Do I need a system of units? Do I need a system of units? Yes, Gulsisa, Teja, I'll be doing classes for 12th also in the days to come. In fact, I think there is one tomorrow itself. Now imagine who was our character? Reuben. Reuben decides I am going to measure velocity as, or maybe length in meters, time in hours. So for him, speed will have the unit of meters per hour, because it is distance traveled per unit time. This is according to Reuben. Then who was our other character? Let's say Vishali. I'm going to take more names, don't worry. Vishali decides length will be measured in feet, time will be measured in second. For Vishali, the speed will be feet per second. Then who comes? Logesh comes. Logesh says, no. For me, length will be in kilometers and time will be in minutes. For him, the speed unit will be kilometer per minute. Look at the mess we are creating. One person will use one unit. What nonsense is this? Welcome, Simi. Welcome to your first day. Crazy, right? Imagine now handling so many units for force, for acceleration, for velocity, for pressure, for temperature. You will go mad. So scientists understood. See, people are mad, people are crazy. Everybody will want one thing. We have to create a standard. So they created standards. But in standard also they created 3 standards. I'm like, really? Sit together, man, and figure out one standard. No, they created 3 standards. One is MKS, one is CGS, and one is foot system. I mean, I'm pretty sure you know this. Like if you go to US, they have miles per hour. Everything is in miles per hour. Gallons. My God, why don't you measure in liters? Really? Gallons. And it's crazy, you know, the conversions. Like, I don't know, 3 feet is 1 yard, so many yards is 1 furlong, so many furlongs is something else. It's madness. I mean, the SI unit is so simple. 100 centimeters is 1 meter. 1000 kilometers is 1 kilometer. 10 millimeters, everything is in 10. Very easy to remember. These foot, pound and second system is very crazy. So there are multiple ways in which you can express anything. So to make a standard, we have 3 systems. MKS, CGS and FPS. FPS is foot, pound, second. So for length you use feet. For mass, you use pounds. For time you use seconds. That's FPS system. In CGS system, you use centimeter for length, you use gram for mass, and for time you use seconds. In MKS, you use for mass you use kg, for length you use meters, and S is seconds. So this is M stands for meter, K stands for kilogram, S stands for second. So MKS. It is also called as SI units because remember there are more than 3 fundamental units. Later on this becomes SI units, which includes other fundamental quantities. Other fundamental quantities. Example like temperature. Temperature is measured in Kelvin, and luminous intensity is measured in candela. Current is measured in amperes, and so on and so forth. You get to measure all the other things. So that MKS only extends into SI, system of units. SI stands for system of units. Okay, all right. So you just need to know that there are multiple systems, but in JEE you mainly deal with MKS and CGS. You don't deal with FPS. FPS is not used in JEE or NEET. Okay, you'll be using MKS or CGS. I hope everybody loves MKS and CGS units. So which of the following physical quantity has the same unit in both CGS as well as MKS unit? There is one quantity where you don't need to convert things. Come on. MKS is a subset of SI. SI is a superset. So MKS just has 3 things: mass, length and time. SI has other things also like temperature, mole, all those other things. So it's just a superset SI unit. I hope Joyce Mary, that is fine. No problem, Pikachu, me too. Wow, what a name. You can join in even now, trust me. Yes, everybody with me on this? Option C, C for capto, C for correcto. Oh, amazing. C for correcto, C for capto. Amazing, oh guys, amazing. Oh, you can see second. All the 3 units, the second is the same. Only problem happens with mass or length. So that conversion is different. Awesome. Moving on to the next one. Which of the following is not a unit of time? Which of the following is not a unit of time? Solar year, tropical year, leap year, light year. C for currency. Okay, interesting. So come on guys. Solar year, tropical year, leap year, light year. Which of them is not a unit of time? Time can be measured in seconds, hours, minutes, years. Everything has year. You'll be like, sir, something is fishy. Everything has year. But the correct answer is light year. So a lot of people do not know light year is not actually time, it is the distance. In fact, light year is the distance traveled by light, in 1 year. And that is huge, guys, because in 1 second itself light travels 3 lakh kilometers. In 1 second it travels 3 lakh kilometers. So you can imagine in 1 year, by God, it's going to travel crazy amount of distance. So that is the unit of distance. So this is actually the unit of length or distance. Exactly. Everything else, solar year is how much time it takes for 1 year. Tropical, it's based on seasons. Leap year, obviously every 4 years you get a leap year, and so on and so forth. Now let's talk about dimensions. Yep, it is going to be very huge, Stefana. Very true. I mean, imagine somebody asking you walk for 2 light years. You'll be like, what? No. So the closest stars itself are very far away. They are like some hundreds and thousands of light years from Earth. Okay. Now, many students often get confused between, sir, what is the thing between physical quantity, units and dimensions? I understood when you told what is unit and what is physical quantity. Remember, I just told you about that. Where did it go? Yep, here. Yes, physical quantity and unit. They are different things. Physical quantity is expressed in certain units. Like I can express length in meters, kilometers, light years, whatever you want. Unit is that standard. But what is this dimensions? You might have heard this word dimensions. Now when you look at the definition, it looks crazy, but it's actually very simple. There's a very small difference between units and dimensions, and I want you to know this. Dimension is basically defined as dimensions of a physical quantity are nothing but the powers to which a fundamental unit must be raised in order to get the unit of the derived quantity. In order to get the unit of the derived quantity. Like, I'll tell you, very simply put. Imagine I tell you volume. Imagine I tell you volume. When I say volume is usually expressed in cube of the meters or cube of the centimeters. Like I can say, example, 1 centimeter cube, or I can say 5 meter cube, and so on and so forth. Now, centimeters, meters, which fundamental quantity are you referring to? Which fundamental quantity are you referring to? Obviously, the unit of, it's basically length. It's length. So, volume is basically having the dimensions of the fundamental quantity is length, and you're cubing the length. So, length cube. This is the dimension of volume. Whenever you have to express dimension, you always put square brackets. So the dimension of volume is represented as by putting square brackets. That means I'm asking what is the dimension of volume. Volume is centimeter cube, meter cube, or something cube. So centimeter, meter, etc. Their fundamental quantities is basically length. So length raised to what? 3. That's all. Similarly, if I ask you, maybe on the next slide, guys, come on, tell me the dimension of velocity. Just think, how is velocity expressed in general? You will express it in meters per second, or centimeters per second, or feet per hour, or kilometer per hour. So what is that fundamental quantity are you trying to express it in? You are trying to express it in meters, centimeters, feet, kilometers. That fundamental quantity is nothing but length per second. Per second, that means divided by time. Time is that fundamental quantity. So the dimension is L by T. You can also write it as L raised to 1, T raised to minus 1. Everybody with me on this? L raised to 1, T raised to minus 1. KVPY exam only is cancelled, Pujit, so there will be no KVPY batch. Now, similarly, if I ask you what is that of force? So for force, you will be like, sir, force is mass into acceleration. So do not leave it over here, because acceleration is no longer fundamental. It's still not the fundamental. Think what is more fundamental than acceleration. Acceleration is how much the velocity changes with time. Is velocity fundamental? No. What is more fundamental than velocity? More fundamental than velocity is length by time. So it will be length by time, and this will be time. So I can just write it as m. This is mass into the length, mass into the length divided by the time square. So hence the dimensions of force, the dimension of force will be mass power is 1, length power is 1, time power is minus 2. That's how you get the dimensions of force. Now this way you can find the dimensions of anything if you know the formula. Slowly in physics you're going to learn different formulas, be it for pressure, be it for flux, be it for field, be it for energy, work, so many things you're going to learn. So when you know the formula, you will automatically be able to find the dimensions. Now what is the most unfortunate thing about this chapter? Do you know physics teachers have to face so much of trouble in this chapter? So many students also give up on this chapter. You know why? Because if you open the books and see now, suddenly you will see Maggie. You will see Maggie in the textbook. Yes, you will see Maggie in the textbook. The Maggie looks like this. Maggie, like this. Then you will see 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 also some cockroaches running over. Some weird symbols you will start saying. Sir, what is all this, sir? I don't know the dimensions. And crazy dimensions. M1 raised to the L cube, T raised to minus 4, ampere, Kelvin, so many things. Sir, I can't buy it. I give up. I don't understand physics. Close the book, throw it, that's it. Play some game. This is where I need to stop you. See guys, these things you will learn next year. So wait for that. Now you know basic things. What do you know? You know work, you know energy, you know power. You know basic things. Velocity, acceleration, momentum, basic you know. Only that much you solve. After that, slowly you will learn new things. Angular momentum, torque. You don't know much about it. You will learn it. And then once you know the formula, you will be able to calculate the dimensions within, I say, seconds, just like you calculated for this. Very easy. Okay? So don't worry. Yes, I know it is epsilon naught, Hamiltonian, and some of you might have already started some coaching, and then you would have seen some crazy symbols. है ना? Crazy symbols. Something and all is there, sir. What is that, sir? Please tell me that, sir. Don't get scared. These are things which you learn during the course of physics, maths, and other things. So don't worry. Crazy things are there. Okay? After some time, you'll be like, simple. It's just like telling a second standard kid, hey, you know, I can solve this equation, root x plus x minus 1 is equal to 0. You will be like, what? What is this? And how is there an alphabet with a number? I just thought there was 1, 2, 3, 4. My teacher just told me 1, 2, 3, 4. And this is alphabet. How is alphabet with a number? I don't understand it. He'll go crazy, no? Same way, you'll also go crazy initially. But later on, you'll understand, oh my God, it all makes sense. Why was I taking tension? Cool. So, talking about the fundamental dimensions. Yes, fundamental dimensions out here. Yes, kind of Arabic says Kushi. All right. So, Greek and Latin. Okay. So, mass, length, time, current, temperature, amount, luminous intensity. Mass m, m raised to 1, m raised to 2, m raised to 3. Length, L raised to 1, 2, 3, minus 1, minus 2, whatever. Time, T, symbol is T. Current, amperes, A. Temperature, Kelvin. Kelvin is another unit like Celsius and Fahrenheit. So that's why K. Amount, moles. 1 mole is 6 into 10 to the power 23. Number of things. It's a mole. You will learn it in chemistry. Luminous intensity, that's candela. These are the important things that you should know. Everybody should by heart this table. I mean, there is no option to that. Chipmunk, practice. Chipmunk. My God, chipmunk, what a name. There was a monkey recently. Reminds me of you now. In my gallery. I just went to keep my shoes and that monkey is staring at me. And he's not eating bananas. He's eating the apple which I kept on my dining table. Imagine that monkey, just because I left my door open, it came inside my room, took out the apple which I was supposed to eat, and it is eating in front of me. I felt like slapping that monkey. I showed him the shoe. It's still not budging. I showed him the second shoe. Still it is not going away. What to do? Monkeys these days. Okay. Now going on to the next one. Guys, I'm using blackboard. Reason being, it's very pleasant on the eyes. White is too bright. And even if you're watching this lecture, maybe in a dark room or, even in the night, it's very pleasant to the eyes. Okay. Hi Sasuke. Welcome, bacha. Super, very good Charita, awesome. Yeah, Shreya, oh my God, you have my similar name. And Shreya, oh my God, is that banana in your name? Or is it a moon? It looks like banana, I'm not sure. Finding the dimensions, I just explained it to you how you are going to find the dimensions. This is the way you're going to find dimensions of any physical quantity by knowing the formula. So to find dimensions, you should know either the formula or you should know the unit. You should know the unit, like meters per second, kilometers per hour, etc. Both are fine. Yes, I am trying. Oh, it's a moon. Okay. We are trying to get that black screen on the platform as well. It will happen soon. I play a lot of games. Yes. Okay. Guys, I'm very far away from the screen. I can barely, just make out few things. Okay. Chalo. Which of the following pairs of the physical quantities, this is a PYQ, has the same dimensions? Same dimensions. Sir is jealous of the money which he saw. Which money, man? Thank you, Akshaya Sai, so much. So, which of the following pairs has the same dimensions? Hi, Logesh. Come on, bacha. I took your name. I wrote your name also. What games? My goodness, Chipmunk. I play kind of simulators and obviously PUBG and all of that. And all those random arcade kind of games. Yeah, that's what I do. And obviously racing games. But mostly on my iPad. And sometimes on the Xbox. Okay, so D for donkey. Everybody, D for donkey. Work and energy. Okay, let's see. Yes, D for donkey is correct. Work and power, no, they are two different things. Work by time is power. By time. So obviously, no. Momentum and energy, come on, two different things completely. gone. Force and power, come on, it's different, guys. Force is in newtons, power is in work per unit time, completely different. Work and energy, they are convertible. Whatever work you do gets converted into energy. So kinetic energy, potential energy, work, everything is in joules. Joules, everything, heat, joules, all this heat, work, energy, all are having the same units. They just have different names because they represent different things. So in fact, there is a question which is there in many books, and it says, can two physical quantities have the same dimension? Can two physical quantities have the same dimension? The answer is obviously yes, because work and energy are two different physical quantities and they have the same dimension. Yes, it is possible. Okay. Now, like the title of the video says, what are the uses of dimension? Now that you know what is the unit, what is the dimension? Unit is like centimeter, kilometers, meters, etc. But they all have the same dimension, and that is length. Kg, grams, pounds, they are units. They all have the same dimension, that is mass, m. So now you know the difference. So what is the use? Why are we studying? Sometimes it can be useful for eliminating options in your multiple choice examination questions or exams. So whenever you have MCQs, you will see dimensions is a trick given by many teachers or even institutes to in fact eliminate or select an option out of the many options. And that principle is basically dimensional consistency. If an equation is dimensionally consistent, we mean that in an equality or an equation signified by equal sign requires not only that the value be identical, but also that the units be same on both sides. And it makes sense. What I mean by this is that imagine, just imagine, I say that Sai Charan has 5 mangoes at home. Can I ever say 5 mangoes is also equal to 5 oranges? Definitely not. Can I say it is equal to 2 oranges? Definitely not. But can I say Sai Charan has a height of, or let's say Sai Charan, what's your weight, bacha? Sai Charan, what's your weight? Okay, I'll just assume it before you can write it. I hope you are not this much, but I'm just assuming. Sai Charan's weight is 70 kg. Sai Charan, don't hate me for this, okay? Sai Charan's weight is 70 kg. Okay, now, can I say 70 kg is equal to 70 grams? Obviously not. Obviously not. Can I say 70 kg, this is not equal to 70 kg, this is also not equal to, by the way. Can I say 70 kg is equal to 5 feet? What nonsense. No, this is mass, this is length. How can we equate the two? So, there is only one way, and that is 70 kg has to be, it could be either 20 kg plus 50 kg. This is also fine. Oops. 50 kg. This is fine. I can also write 70 kg is equal to 2 into 35 kg. This is also fine. I can also say 70 kg is also, I can say 70 into 10 to the power 3 grams, because I know kg, kilo, k stands for 10 to the power 3. Kilo is 1000. So this is k into grams. This is also fine. All these are fine. These are not fine. I hope this is clear. Yes, Domanti, my Pathfinder series is useful for 2023 and my Nurture series is useful for 2024. Oh, nice. Shreya is our AI Live JEE student. Awesome. Okay, great. So even when you see these kind of equations, right? S is ut plus half at square. Believe me, everything has the same dimension, and that's what we're going to see in some problems now. Let me just probably tell you about, let's say, an equation like V is equal to U plus A into T. Velocity has the same dimension as that of initial velocity and same dimension as that of acceleration and time. This is equal to, I'm just going to put equal to because you can only add two things or subtract two things which have same dimensions. You cannot add oranges and mangoes. Oranges plus oranges, fine. Mangoes plus mangoes, fine. Oranges plus mangoes, not fine. So velocity has the same dimension as initial velocity, has the same dimension as acceleration into time. So you can rearrange stuff you can rearrange stuff, and I can also say acceleration has the same dimension as bring that time below, initial velocity by time. This is also fine. So whenever you add and subtract, you will see the dimensions of the terms being added or subtracted should be same, because you can only add similar dimensions. You can't add length with mass, mass with time. You cannot add or subtract. Mass goes with mass, length goes with length. Okay, great, great. Moving on to some questions coming up on your screen. Awesome, Kushi. I'm so glad all of you already attending Vedantu classes and the YouTube classes. Hats off to you guys. Hello, Angar Khani. Oh, Sai Charan, you are in class 10th, bacha. Bilal, maybe soon, very soon, maybe for the next example. Distance traveled by a particle at any instant t can be represented as, this is S is distance, a into t plus b plus ct square. Some equation, who knows? Don't care about where it came from, just some equation. The dimensions of a, b, c are. Okay, let's try to understand this. What is it given? S is a t plus, what is it? A, b, and plus c t square. Now in this equation you have to find the dimensions of all the numbers like a, b and c. One thing I know for sure, that the dimension of s should be equal to the dimension of at, should be also equal to the dimension of ab, because all of them are added, also should be equal to the dimension of c and t square. Everybody agrees with this? All these dimensions should be same. Everybody with me on this? Excellent. They are consistent. Excellent. Now, question is, what is them? What is their dimension? I know what to do. Look at this. I know how to deal with a first. So for a, what I will do, the dimension of a will be the dimension of s upon the dimension of t. Oh, s is distance. S is distance. Distance is measured in length. So this is length, and time is basically t. So this will be nothing but L raised to 1, t raised to minus 1. Excellent. So that is the dimension of a. That is the first answer I got. First answer, L raised to 1, t raised to minus 1, by just looking at these two. Interesting. I think I can also get the dimension of c. How do I get it? Look at this. S dimensionally is also equal to dimension of c and dimension of t square. T square means this. Now bring t square below. So c will be dimension of s divided by dimension of t square. Now s is nothing but length. So this is L, and this is nothing but t square's dimension. So this will be nothing but L raised to 1 and t raised to minus 2. So that is the dimension of c, of course. Do you see that, guys? So I found A, I also found C. The only thing left is B. Oh, how do I deal with that? Oh, I don't even have to go over here. Although I can. I know A, I know S, I can find B. Or just look over here. It becomes very easy. If you look over here, it becomes easy. You are adding T and B. If you are adding T and B, that means the dimensions should be same. So the dimensions of T should be equal to the dimensions of B. Done. So the dimensions of B is basically t raised to 1. That is my third answer. Done, done, done. A, B and C. Excellent. Yes, Ruben, I can do the dimensions of B by dividing S with A also. I will still get the same answer. It's not going to be different. You can try it out. Dimensions of B will be by this equation. Dimensions of S, take A below. So dimensions of A. You can try it out. You will still get the same answer. It's not going to be different. You will still get this only. Cool. So you can find the dimensions and you can see whether it makes sense. If you see some equation, something is wrong, sir. One option, imagine in the exam, there is one option which looks like this. One option which looks like this. Distance is equal to acceleration into time. This is, let's say, option B. You will immediately think distance. Distance is length. Acceleration, that is meter per second square. That means L raised to 1, t raised to minus 2. Time is just time. Okay, when I multiply them, I'll get L raised to 1 and t raised to minus 1. Oh my God, look at this. They both are not equal. Hence, this option is wrong. This option is wrong. That is what you're going to think in the exam, and that's how you're going to eliminate the option. Kailash, the lecture for 12th is coming tomorrow. Got it? Everybody with me on this? So this option can never be correct because it's dimensionally wrong. Okay. Now let's do the final part, and that is basically dimensional analysis and unit conversion. So first use I have told you is to check whether LHS and RHS or the terms being added and subtracted have the same dimensions, can be used in objective exam. Another use is for converting one unit to other. Example. Let's say, speed. Okay, let's say for speed. Let's take an example of speed. And let's say, I want to say, how much is 1 kilometers per hour in MKS or SI units? So what I'm going to do is I'm going to write 1 as it is. Kilometers, 1 kilometer is how many meters? 1 kilometers, yes Shreya, very good. 1 kilometers is how many meters? Think about it. 1 kilometer is 1000 meters, right? 1000 meters upon R. Do not want R, I want second. 1 hour is 60 minutes. 1 minute is 60 seconds. So 1 hour is 60 into 60, that's many seconds. So 60 into 60 seconds. Everybody agrees with this? Very good. Now let's cancel. 0, 0, 0 cancels. So I'm just left with 10 by 6 meters per second. Oh, that also I can simplify. Oh, sorry, 6 into 6, my bad, 36. So sorry guys, I forgot that 6. So 6 into 6, 36. Now this also I can simplify. So this will become nothing but 5 by 18 meter per second. Now here I have 1 kilometer per hour. Now what you learned from this is that this is your magnitude. So I can call it N1. This is nothing but your unit, U1. This is again a magnitude, which is N2, and this is nothing but another unit. You can see N1 U1 is N2 U2, meaning the physical quantity did not change. The car is still going with that much speed only, whether I tell 1 kilometer per hour or whether I tell 5 by 18 meters per second. It does not mean I am increasing the speed. Sir, 5 by 18 is less, sir, it's small. No, still it means the same thing. It's the same physical quantity. Just because I tell you your height is 2 meters does not mean it is small. If you convert it into feet, you will see maybe it is like 5 or 6 feet. So it's good only. It's the same thing. It's just that the moment you change the unit, you will see it will be balanced by the magnitude. If you increase the unit, the magnitude will decrease. If you reduce the unit, the magnitude will increase. So that's how it is. So that's why N1 U1 is equal to N2 U2. Everybody with me on this? Yep. Yes, Ruben. If you go the reverse way, so 1 meter per second will be nothing but how much? It will be 18 by 5 kilometers per hour. Same way you can do other conversions also. You will learn that 1 Newton is 10 to the power 5 dynes. This is basically SI unit. This is basically CGS unit. You will also learn 1 joule is 10 to the power 7 ergs. Again, this is SI unit, this is CGS unit. This is how it works. So N1 U1 is N2 U2. Okay, that's what is there in this complicated form. If you read NCERT, like, sir, I am fainting, sir. Sorry, what is this? I just fainted, sir. What is this? This is exactly the same thing. If you do it, then it looks simple. If you look at the formula, you will get scared and you will close the book again. So always try to look at things in a very simple manner. Let's have a look at this. Okay, the density of wood is 0.5 gram per centimeter cube in CGS system. The corresponding value in MKS unit is how much? Yes, inverse relation. Yep, definitely Pikachu, me too. Definitely. Yes, Barvanant, Mangama. I'm conducting an Erodo session in just a few days. Monday, I think, I'm conducting a session. The density of wood is this much in CGS. What's the value in MKS? Convert it. Come on, think about it. Same way, 0.5 gram per cc. Okay, so how do you convert it? I want in MKS. That means convert gram into kg, centimeter into meter. Okay, so this is 0.5 gram, cc, it's centimeters cube, it is centimeters cube, great. So this will be 0.5. 1 gram is 1,000th of a kg, or basically 10 to the power minus 3 kg. Everybody agrees? 1 gram is 1,000th, that is 10 to the power minus 3 of a kg. That's how it is. Divided by centimeter. 100 centimeters make up a meter. So 1 centimeter is 1/100th of a meter. That means it is 10 to the power minus 2 meters. But cube it. Do not forget that cube, because 1 centimeter is 10 to the power minus 2 meter. Cube it. Okay, many of you have started putting up the answers. I am very proud of you. Most likely you guys are correct. So this will become 10 to the power minus 3, and this will be kg, and this will be meter cube. And here I will have 10 to the power minus 2's cube, which will be 10 to the power minus 6. So that goes on the top. So it will be 0.5. 10 to the power 6 minus 3, that will be 10 to the power 3 kg per meter cube. So shift the decimal 3 times. So it will be 500 kg per meter cube. So that is what 0.5 gram per cc will be. Simple. N1 U1 is N2 U2. Done, done, done. Very good. Awesomeness. Great, 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 great. Excellent, excellent. Simple na conversion of units. That is how you're going to do it. So you should know everything: centimeter, millimeter, kilogram, meters, everything. If you know the basic stuff, I'm pretty sure you'll be able to solve the questions. Now the last application is the dimensional analysis. This is a magical power, and many people might not like it, especially those who are very serious. Sir, this is such a tricky method, sir. Sir, this is such a, shortcut method. I mean, from this we can get anything. Yeah, you can get most of the things, but not everything. And this is not what physics actually should do. I mean, this is like a shortcut trick to find formulas. But it has its own limitations, like it can't be used for trigonometric or logarithmic relations. It can't be used when there is some addition or subtraction, or things when there are like exponents. You cannot use this method what I'm going to teach you. But in that limited scope, it has its own personality. It can be used in a very beautiful way. What is this method? This method is basically to find some unknown formula, but provided you know what does it depend on. What does that quantity depend on? Even without knowing what the exact law or that theorem or that principle is, you can derive a formula approximately, which is a very good thing. Let's try to understand it. What this principle is based on is, any physical quantity will depend on other physical quantities. For example, this is a physical quantity. Let's say it depends on P1, P2, and so on and so forth. Then the final physical quantity might look like this: some constant P1 raised to X, P2 raised to Y, and so on and so forth. And I'm interested, what are those powers? What are those powers? Example, to just give an example, kinetic energy is half mv square. Now kinetic energy is this physical quantity. This constant is half. P1, P2 are m and v. How? You can look at it this way: half into mass raised to 1, v raised to 2. You can clearly see this. Are you seeing the resemblance right over here? Everybody with me on this? Kinetic energy is half into m raised to 1, v raised to 2. This P1 is m, x is 1, P2 is v, y is 2, k is p. So many formulas like this will hold true. Many such formulas for time, for speed, for distance, acceleration, who knows? Yep. Is strain dimensionless? Yes. Yep, it is. This is the 2024 batch, Lakshmi Pita Reddy. This is for 2024. Please read it. Yeah, this is for 11th standard. So, whenever you know that a physical quantity depends on the powers of other quantities, you can make use of dimensional consistency. I know that the dimension of P this constant is dimensionless. If constant has dimension, then you cannot use this method. Will be equal to the dimension of P1 raised to x, dimension of P2 raised to y, and so on and so forth. And then you can compare. Acha, here m has some power, here L has some power, here time has some power. The power of m should be equal to whatever that power of m is, that same power should be there here also. These two should be equal. Same way, the power of length, whatever is there here, the same power should also be there here, and so on and so forth. So comparing them, you can get x, y, and z. Okay, so that's the method. I will show a demonstration so that you get an idea. Everybody with me on this? Shall we see a demonstration on this? Shall we see a solved example on this? Let's try to do a question on this. Okay, if the time period of a pendulum depends on the length and the acceleration due to gravity, then guess the formula dimensionally for the, oh my god, why are the spelling mistakes? For the period of, oh my god, oscillation. Okay, let's try this out. Now, a pendulum, this is a pendulum, it oscillates back and forth like this. Okay, it oscillates back and forth like this. It obviously has some length and there is some acceleration due to gravity, L and G. Now, the time period depends on the length and G. Let's try to first of all think what are the dimensions of the time period. The dimensions of the time period will be obviously t raised to 1. Dimensions of the length will be obviously L raised to 1. Dimensions of acceleration due to gravity, it's meters per second square, correct? Meters per second square. Meters means length. Second square means t raised to 2, but per second square, so t raised to minus 2. So meter per second square. These are the dimensions of each of these things. Now I will assume that the time period is some constant into L is the first physical quantity raised to x and gravitational acceleration is the second quantity raised to y. I do not know x and y. I'm trying to find and guess that formula. Okay. So according to our hypothesis, the dimensions also should be equal on both sides by dimensional consistency. So here is what I'm going to do. So the dimensions of time should be, constant has no dimension, will be dimensions of L. L is nothing but L raised to 1. So L raised to 1 x and G is nothing but L raised to 1 t raised to minus 2 and y. Let's try to solve this further. So dimensions of time will be, here I have L raised to x, here I have L raised to y. So the dimensions of length will be L raised to x into L raised to y. L raised to x into L raised to y will be L raised to x plus y. Correct? And here there is no time, but time is there over here. So time raised to minus 2 raised to y. That means time raised to minus 2y. Everybody with me on this? Everybody with me on this? Yep, very good. So now that you understand that L raised to x, L raised to y, I have taken it together. T raised to minus 2 raised to y is t raised to minus 2y. Just compare. Whatever terms are there here and here should be identical. Let's try this out. The power of time over here on the LHS is 1. On this side, it is minus 2y. So by comparing, so what am I doing? By just comparing, okay, first for time, 1 is equal to minus 2y. That means y is nothing but minus 1 by 2. Interesting. Great. I just got the value of y. Last thing. Here, if you compare, there is no power of length. On the LHS, the power of length is 0. There is no length at all. And on the right hand side, it is just x plus y. Therefore, x will be minus y. Therefore, x will be minus of minus half, minus of minus half. Therefore, x will be plus half. Now look, okay sir, I got the value of x and y. Now what to do, sir? Come on, tell me. Okay, it's simple. Here is what I'll do. Just substitute it in that assumption. Just substitute it in that assumption. So time will be c into L raised to x. What is x? Half. L raised to half. Gravity raised to y. Y is nothing but minus half. This I can further write it as g root L, and this will be 1 by root g. So I can write this as c root L by g. Exactly what I want. This is the final formula. Now, guess what? when you study this chapter in 11th grade later on, you will actually derive it using a very nice procedure. And when you actually find it out, this was the formula which I guessed, but the actual formula is this: 2 pi root of L by G. This is using proper mathematics, which you will learn later on. But this is so accurate. The constant is 2 pi, root L by G is as it is. That's the beauty of this method. You can find some unknown formula only if you know what does it depend on, and provided it meets certain criteria, like the constant should not have dimension. You can only use it when it is in this form. If there is plus or minus sign, you cannot use. Trigonometry, exponents, logarithm, you cannot use. But all the other simpler formulas, you can use it. I hope this is clear. What is the value of y? Lakshmi Pratit Reddy? It is minus half. Hello, Shirish. Okay, great, Ruben. So it's a beautiful method. Now, how about doing some homework? And I would love to see all your comments in the comment section after the session is over. This is the first question for you, and this is the second question for you. The answers will also be uploaded in the Telegram channel, so make sure you check it out after the session is over. Maybe maximum one day the PDF gets uploaded. Okay, so I hope you guys have enjoyed the session, and my batch for 2024 is going on right now. I'm not sure how many of you have seen that batch. Some of you are already my students from the AI Live batch as well, like I can see. So there is NEET batch, there is JEE batch. Both the batches are there. So let's say, for example, you are a NEET student, you are going to click on this course price for 2 years. My goodness, it's not 1,48,000, guys. I mean, that's also less. 1,48,000 is the fee for 1 year in offline coaching, and this is the fee for 2 years in Vedantu, and you get everything. Like, you have in-class doubt solving, you have quizzes, leaderboards, you have VIP, that means if you do not improve, fees are returned back, assignments, class notes, all India level test series, and you also get study material PDF form. But you are like, no sir, I don't want to watch AI live class because it's recorded, but everything else is live, like the quizzes, everything is live. Okay, all students are live, interactions are live, the second teacher is live. Like, no sir, I want to watch a live batch. No problem. There you have Pro Lite and Pro Classic. So in Pro Lite, Pro Classic, you get the live interaction like you can see over here, and additionally you get books. That is the hard copy of the soft copy. That's all. It's the hard copy that you get. You get live discussions, and also you get doubt solving after the sessions are over. And you can see it's priced accordingly: 69,300, 87,120 for 2 years. Yes, these are 2-year prices. Options of EMI are also available. So if you go for the lowest version, you can save 1650 rupees using my coupon code SHHPRO. Multiple options. Again, you can see right over here. And the same thing you can see even for the highest version right over here. Even though it says 87,120, look at the beauty of this. You have saved 9,680 rupees. Oh my God, using my coupon code. And the best part is you can go for 0% interest rate EMI options. Like for 12 months, you can see it comes down to 7,260 rupees. So you have those easy peasy options available for you, which can be a little bit good on your pockets. By the way, there is this JEE batch also, and that is also the same price. All retails are exactly similar. There is no difference in pricing, whether you go for JEE or NEET batch. And like you can see, both options are available: English as well as Hinglish. Hindi English, that's English, and you have English option as well. So how was it, guys? Already purchased, very good, Khushi, and I know some of you are already there in my batches. I'm so glad you guys are there, and please continue in watching these sessions as well as the pro batches. That will be the ultimate mantra for your success, all right, in the days to come. So this was just the first lecture of your 11th standard, many more lectures to come, and some of you might already know this, but still I will just show this to you. There is also this amazing playlist, guys, of all the lectures that I have conducted in the last year. And it's not like it's invalid, it's still valid for both JEE and NEET. Just click on this nurture playlist, 11th standard. Okay, you can just click on this view full playlist. You can see all lectures, right from units and dimensions, vectors, all right, 1D kinematics, everything is there right over here till the last chapter. So I won't be repeating exactly the same thing, whatever I have done. I would expect you to go through these lectures as well at times, and we'll be doing something which will complement these lectures which will build up more concepts, which will be like more numericals, more application or more special concepts, which will help you, understand these chapters better. So that is what I'm going to do, and don't expect me to do the exact same thing, okay? I don't want to set up false expectations out here, and that is what we already do at Vedantu Enlite. Like, we deliver our promises, and I'm pretty sure you know about it. I'm so glad Utmost Certainty and Creative Fever, Khushi, thank you guys so much. All right, Pikachu, definitely I will do that. Yep, the series for 12 starting tomorrow, Parmati, Sonanda. All right, don't worry. And take care, guys. Have a great time. Stay safe, stay well, and please do your homework. Put it up in the comment section. I'll be seeing all your comments. Who is going to be really quick in answering these last two questions which I just gave. Bye-bye. Take care. This was Shreyas here signing off. Hasta la vista.